Good afternoon, guys. Yesterday's lecture we have seen the types of the form head. Okay, then so we have seen the one by one plain form head, spherical dish head, semi-elliptical dish head, hemispherical head, and conical head. We have seen the advantages, disadvantages, and application of each heads. Okay, in the today's lecture we will going to solving the numerical on the same, the combined loading and types of the heads. You should remember the formulas. With the help of that formulas we can solve the numericals. Numerical will be asked for the 10 marks or 12 marks on the basis of the same formula. Then we will see the first statement of the numerical. First numerical, a cylindrical pressure vessel is made up of a tensile steel. Okay, cylindrical pressure vessel is made up of material is given tensile steel. Assuming the following data, determine the thickness of the vessel shell. We want to find out which value thickness of the vessel shell. It is denoted by the T. Which value is given? Internal diameter of the vessel is given 1500 mm. Okay, internal diameter of the vessel means di is equal to 1500 mm. Then design pressure, it is denoted by the pi is equal to 0.44 MPa is given. The next, permissible stress for the material. Okay, means permissible stress, it is also called as a allowable stress. Sigma all value is given 130 MPa. And welded joint efficiency, welded joint efficiency is denoted by the NL. 85% means 85 divided by 100, you will get the 0.85. Then see, assuming both ends as a close, what is given? Assuming both ends are closed and external forces as well as corresponding stresses are negligible, means there is no any external forces or corresponding stresses. We are neglect that forces and stresses externally, not internally. Determine the resultant stress in that cell. Okay, determine the resultant stress in the cell, means which value we want to calculate? Sigma r. This type of numerical will ask for the 8 marks. Okay, see, di is given 1500 mm, pi is given 0.44 MPa or Newton per mm square. 1 MPa is equal to 1 Newton per mm square. Sigma all is equal to 130 Newton per mm square. And NL is equal to joint efficiency is given 0.85. The thickness of the vessel shell we want to calculate. Okay, here we have seen the corrosion allowance, right? But here corrosion allowance value is not given. That's why we will consider the corrosion allowance is 0. Okay, assuming the corrosion allowance is 0. We have seen the formula, thickness of the vessel shell T is equal to pi di divided by 2 sigma all NL minus pi plus C. C we are consider the 0. If you are putting the value in that equation, then you will get the thickness is equal to 3 mm. 3 mm. This is the first answer. And how to calculate the resultant stress? Resultant stress, you know that the formula for the resultant stress, we require the tangential stress as well as longitudinal stress. Before going on the resultant stress, we know the value of the tangential stress and longitudinal stress, because we have seen the some theories. Okay, theories of distortion energy theory, then the maximum principal stress theory. Then here we want to use the distortion energy theory. Before going on that, we know the value of sigma T and sigma L. Sigma T is the circumferential stress in pressure vessel shell is pi into bracket di plus divided by 2T. Okay, is equal to, if you have put the value Pi di T, then you will get sigma T is equal to 110.2 Newton per mm square. And similar way, in the longitudinal stress in pressure vessel cell, you will get the formula sigma L is equal to Pi di divided by 4T. If you are putting the value, then longitudinal stress is induced in the given pressure vessel, you will get the 55 Newton per mm square. According to the distortion energy theory, the resultant stress in the pressure cell is sigma r is equal to root of sigma t square minus sigma t into sigma L plus sigma L square plus 3T square. Okay, and we are consider the corrosion allowance is 0. Okay, 3 tau square. Okay, here we are consider the shear stress also is 0 because this value is not given, then you should consider the 0. If you are putting the all the value in square root, then you will get the sigma r is equal to 55.43 Newton per mm square. Then you should check the value of sigma all is greater than that sigma r or not, then you can conclude the given pressure vessel is safe or not. Here we get the 55.43 sigma r value, and what about the sigma all? Sigma all is given 130. Okay, then this 130 55.43 is less than 130, then we can say pressure vessel cell is safe. This type of numerical will ask for the 8 marks. Then next second numerical, see the statement. All of you remember the formulas. Without formulas you can't solve the any numerical. The cylindrical pressure vessel made up of steel. Again here cylindrical vessel pressure vessel is given, made up of steel, material is given steel. SYT is given, SYT is equal to 270 Newton per mm square, is subjected to the operating pressure of 2 MPa. Operating pressure is given 2 MPa or Newton per mm square. Okay, 2 Newton per mm square. Operating pressure, Pi is different and operating pressure is different, remember that. The thickness of the cell and torus spherical head of the vessel. Remember, you should use the formulae related to the torus spherical head. You know that yesterday we have seen the torus spherical formula, how to calculate the thickness. Then see what is the given. The thickness of the cell and torus spherical head of vessel are 12 mm and 16 mm respectively. Okay, both thickness are given. Torus spherical head thickness is given and cell thickness is given. TS is given and TH is given. Both values are given. See, then if the weld joint efficiency is 0.7, NL is given, or we can say the N efficiency is given 0.7 and corrosion allowance is 2 mm. In the last numerical we have seen the corrosion allowance is not given, but in this numerical corrosion allowance is given 2 mm. Then which value is given? C is equal to 2 mm. This is the given data. What we want to the calculate? Determine the inside diameter of the cell and the crown radius of the torus spherical head. Crown radius it is denoted by the RC. Inside diameter of the cell it is denoted by the DI. We want to the calculate that two value with the help of given data. And then how to calculate that value? First, inside diameter of the cylindrical vessel cell. How to calculate that inside diameter? You know the formula for the pressure vessel cell. TS is equal to Pi di divided by 2 sigma all NL minus Pi plus C. This is the formula. Okay, here which value is given or which value is known? We don't know the Pi value. They have given the operating pressure. And how to calculate the inside pressure? or design pressure Pi is equal to 1.05 into PO. Use this formula and calculate. You will get the 2.1 Newton per mm square. Sigma all is equal to, you know that how to calculate the sigma all. Before that also we have seen, right? Sigma all is equal to SYT. Yield tensile strength is given divided by factor of safety. Factor of safety is 1.5 for the given material. Then you will get the sigma all is equal to 180 Newton per mm square. Put this whole value in the TS equation. Then you will get then you will get TS DI is equal to 1190 mm. Then second, crown radius for the torus spherical head. How to calculate the crown radius? You know the again thickness of the torus spherical head is equal to 0.885 pi RC divided by sigma all into n minus 0.1 pi plus C1. Put all this value in that equation and calculate the RC value. Then you will get the RC is equal to 947.5 mm. All of you remember that you should check the which type of the head is given. Here is a torus spherical head is given. That's why you should use the formulas related to the torus spherical head. Then next we will see May 13, 12 marks this numerical is given. A 10 meter cube capacity cylindrical pressure vessel with torus spherical head. Again which head is given? Torus spherical head. Okay, is to be used to store water. Okay, here is they are using that torus cylindrical pressure vessel store the water at a temperature of 160 degrees Celsius. Temperature is given 160 degrees Celsius. Water vapor pressure is 6.4 bar. Water vapor pressure is given 6.4 bar. Absolute pressure is given. Also, the crown and knuckle radii for the torus spherical head are taken as 0.75 di. Crown and knuckle radius is given 0.75 di and 0.125 di respectively. Both radius are given. The vessel shell as well as head are made up of plain carbon steel. Material is using plain carbon steel with allowable tensile stress. Sigma all value is given 85 Newton per mm square. The single butt weld joint with what backing strip, here is a backing strip are given, are used to fabricate the vessel. The total length of the vessel is limited to 5 meter. The total length is given LT 5 meter. Okay, and we want to the calculate first which class vessel to be used for this purpose. First you should tell the class, which class pressure vessel is used with the help of given dimensions data. Second is a determine the pressure vessel diameter and the corrosion thickness of the vessel shell. We want to the calculate the diameter and corrosion thickness, corresponding thickness of the vessel shell thickness. Third is a determine the diameter of the torus spherical head. We want to the calculate the diameter of the torus spherical head. Dimension of the torus spherical head. What is the maximum the opening that can be provided the head? See, we will calculate one by one. First we will check the given data. What is the given? First you have given the volume V is equal to 10 meter cube capacity is given. Okay, meter cube you should convert into the mm cube. How to convert? Meter cube means 1 meter is equal to 1000 mm. Then you will get the 10 into 10 raised to 9 mm cube, right? Then which value is given? Absolute pressure is given. Absolute pressure is given 6.0 4 bar, 6.4 bar, keep as it is, that 6.4 bar. With the help of that absolute pressure, can you know how to calculate the working gauge pressure or working pressure? Okay, working pressure is Pw is equal to absolute pressure minus atmospheric pressure. Okay, we know that the atmospheric pressure, then 6.54 bar minus 1.01325, this is the atmospheric pressure, is equal to, you will get the 0.387 bar. Then again we want to the convert into the Newton per mm square. You know the 1 Newton, 1 bar is equal to 1 into 10 raised to 5 Newton per meter square. Then again we want to the convert into the mm square, then you will convert 0.5387 Newton per mm square. Okay, then which relation is given? There is a crown and knuckle radii for the toruspherical head are taken 0.75 di, means RC is equal to, one relation is given 0.75 di, and RIC is given 0.25 di. Remember that two relations are given. Sigma all is equal to 85 Newton per square. LT is equal to length, total length LT is equal to 5 meter is given. 1 meter is equal to 1000 mm. Then we will convert into the 5000 mm. Then see, we have seen the class 1, class 2 and class 3 pressure vessel. What is the pressure inside the class 1, class 2 and class 3, or what is the temperature inside the pressure vessel as per the class 1, class 2 and class 3? As per the given data, you should check which class is given. We will check that details. The vessel contents is water. Yes, this is filled by the water, and also the operation is above minus 20 degrees Celsius. Hence, its pressure vessel 1 is not required. Class 1 is not required. Okay, the gauge vapor pressure is 5.387 bar is given, which is greater than 3.5 bar. 3.5 bar. Hence, class 3 vessel cannot be used. Below that 3.5 bar, we can use the class 3 pressure vessel. Therefore, you have given the class 2 pressure vessel. Here is the first answer is your class 2. You should remember the difference. You should the range of the in the class 1, class 2 temperature and pressure range. With the help of that, easily you can identify which class is given. Then diameter of the cell, we want to the calculate, determine the diameter of the cell. How to calculate? I have shown the here figure. Okay, you know the meaning of each and every thing. Yes, from figure we want to the calculate the width of the pressure vessel. B is the width of the pressure vessel. How to calculate? RC minus AC. Then here we have seen in the last lecture toruspherical head, right? There we are using the Pythagoras. Again here we will use the AC. AC is equal to BC square minus AB square, means you will get the B is equal to RC minus root of under root of BC square minus AB square, right? Then you will get the RC is equal RC minus root of RC minus RIC bracket square minus again di by 2 minus C. Okay, in that equation if you are putting the given relations, okay, this relation RC is equal to 0.75 di and RIC is equal to 0.125 di. Okay, these two value if you are putting in that equation, you will get the B is equal to you will get the 0.25 di. Then what about the length of the pressure vessel including the straight flange is? Okay, see the length of the pressure vessel, it is denoted by the LS. LS is equal to 1 minus 2B minus 2TH. Okay, B is very small as compared to the LT. B is very small as compared to the LT, and B hence neglecting the TH value. We are neglecting the TH value. Okay, then you will get the new value for the length of the pressure vessel. LS is equal to LT minus 2B. LT minus 2B, because this thickness we are neglecting. Okay, because of very small we are not consider. Remember that LS is equal to LT minus 2B. You know the B value, we have calculated 0.25 di. Put in that equation, you will get the LS is equal to 5000 minus 0.5 di. Then we have given the storage capacity of the pressure vessel, right? What is the storage capacity of the pressure vessel, or how to calculate? V is equal to volume stored in the vessel cell and straight plunge portion. There are two portions. One is given for the straight plunge portion, and second is a torus spherical head. Okay, both side torus spherical head is given. Here we are missing here 2 into. Okay, volume stored in a torus spherical head excluding the straight plunge portion. Okay, we know that there are two portions. See that in that figure, this joint to joint there is a one portion, and here is a torus spherical head is there in the both side. Then see V is equal to, you know the area for that, volume for that, pi by 4 di square into ls, plus y2 into, because of two torus spherical head, the both end into 0.08467 di cube because of volume. If you are putting the all the value in that equation, then we are using trial and error method, then we'll get the di value. Okay, di value, or you can use the quadratic equation, you know, plus or minus b minus root of b square minus 4ac divided by 2ac. Okay, use that equation or use the trial and error method, then you will get the di is equal to 1680 mm. We are consider the 1700 mm. You will get the second answer, di. Then third is a thickness of the pressure vessel cell. How to calculate the thickness of the pressure vessel cell? The pressure vessel is made up of which material? Plain carbon steel material. The operating condition are not severe. Hence the corrosion allowance is taken as a 1.5 mm. In the class 2 pressure vessel or spot radiography, there is a, we have seen there are different categories of is given for the welding joint. There is a fully radiograph, then radiography, and there is no radiograph is used. Okay, there are three categories is there. But in the if you have designed the pressure vessel in the class 2, then you have to use the spot radiography technique. Okay, therefore for a single welded butt joint with backing strip with a spot radiography, the welded joint efficiency is 80%. What about the efficiency is 80%? Then design pressure is equal to pi is equal to 1.05 into pw. Pw is the working pressure, this is given. Then you will get the design pressure 0.5656 Newton per mm square. Then you know the formula thickness of the vessel cell is given by Ts is equal to pi di divided by 2 sigma all nl minus pi. If you are putting the value in that equation, all value is known, 8.6 mm, we will consider the 9 mm. For the design, safety of the design, we will consider the next digit. That's why you can keep as it is. There is a little bit change in your answer. Okay, Ts is equal to 9 mm. Then second last, we want to calculate the thickness of the torus spherical head. How to calculate the thickness of the torus spherical head? Yesterday we have seen the formula. We know the RC value. We know the RIC value. Okay. Also we required the KF value, stress intensification factor. Okay. Yesterday we have seen that. To calculate that, and what is the relation we have seen. okay, which were there are two value is given. One is a 3 th value is given or 20 mm, which will get maybe larger. You choose that value for the answer of that SF, stretch plunge length, SL. Okay, then we will see one by one. Knuckle radius RIC is equal to 0.125 di. We have calculated already di, right? Put this value 1700, you will get the answer. Then crown radius RC is equal to 0.75 di. Again put the value of di, you will get the 1275 mm. Then kf is equal to 1 by 4 in bracket 3 plus root of RC minus RC divided by RIC. If you have put both the value, then you will get the kf 1.3624. Then thickness of the torus spherical dish head, you know the formula, th is equal to kf into pi RC divided by 2 sigma all n minus 0.2 pi plus c. Okay, if you are putting all this value, then you will get the 8.73 mm. You should take the next digit or 9 mm. You will get the answer th equal to 9 mm. The straight plunge length. How to calculate the straight plunge length? Straight plunge length is equal to 3 th or 20 mm, which were larger. Already I have told. 3 into 9 you will get the 27. 27 is large or 20, 27 is larger, that's why we will take the straight plunge length cell is equal to 27 mm. And last is a maximum size of opening in the head. What is the maximum size of the opening of the head? That outer diameter divided by 2. The maximum size of the opening can be provided the head DC maximum opening is equal to DO by 2. We know how to calculate the DO. Again DI plus 2TS divided by 2. If you are putting the value, then you will get the here is equal to maximum opening is equal to 859 mm. Student, remember that we have seen the different formulas. With the help of that formula, you can solve the numerical easily. But you should remember the all the formulas and condition is given for the different heads. Okay, we have seen that. Then after that, okay, after that. The next bit is a nozzles and opening is unfired pressure vessel. This is the last bit in your syllabus. Nozzles and opening in unfired pressure vessel. Openings provided. Why we are required the opening? For the functional requirement. First, inlet and outlet connection. If you have given the inlet and outlet connection, you can say the opening is required. Inlet also and outlet also. Drain pipe connection. Okay, drain pipe connection. Second, pressure gauge connection. You should check the pressure of the pressure vessel. Then there are some safety devices required. Safety devices connection. Then manhole. If there is any maintenance, then we want to use the manhole. And nozzles are formed or welded around these openings. Okay, with the help of different welding joints. Opening or holes are create stress concentration in the vicinity of the openings. If you have removed the some area, then again you should add the some area at that place. Then how to add that? Because of there are creating some stress concentration in the opening or uh, outlet or drain pipe connections. Okay, stress concentration. How to reduce that stress concentration? Stress concentration is reduced by the providing that area reinforcement in the vicinity of the opening. Okay, how to achieve by that? Any one or combination of that we are using. Okay, with the help of that we can achieve the reinforcement, providing additional thickness of the vessel wall itself near the nozzle. With the help of that we can achieve the reinforcement. Second is a use of separate reinforcing pad attached to the vessel wall. Means you have to attach the separate reinforcement wall covering or area surrounding the opening. If you have removed the material at that place of the opening, then you should add the some material, okay, that material around the vessel, okay. And third is a providing additional thickness to the nozzle. This is the some steps to achieve the reinforcement, okay. Most widely used method there, area for area method of compensation, okay. This method will ask so many times in the examination. Guys, you can check the last year question paper. I have uploaded that question paper in the Google Classroom. You should check that question paper. Each and every question paper you will get the question on area for area method of compensation, okay. What is the area for area method of compensation? We will see in the next lecture. Today we'll stop here. Thank you. उन्हात का थांबलाय.